All right, review sessions. Here we go. These are all posted on Classroom as well. If you don't pick it, if you forget any of these, if school's in session, I'm here. Okay, school's Wednesday, Thursday, Friday afternoon. I'll be here if you want to stop by at all. I know you guys have exams going on. I'm sure other review sessions for other classes. I get it, but I just want to let you guys know I will be here during the school day, with the exception of Friday morning. All right, Friday morning I got to correct some other exams, so I will not be available Friday morning. But any other time, I'm good. Outside of the normal school day, this Saturday I'll be here from 12 to 2:30 in the classroom for anybody that wants to review. Also Monday 11 to 2. We don't have school next Monday, but I will be here 11 to 2 in the classroom. I highly recommend. I'm not guaranteeing the front door is going to be open as far as the school front door. So your best bet is to come and get dropped off back here, okay, and enter the school through the back door down here. All right, I can have that open. I can't guarantee the front door though. All right, so I can guarantee to have that open. This is come and go as you please. You want to stay for 10 minutes, you stay for 10 minutes. If you have a friend that takes geometry as well, they can come as well. But this is a business session. It's not a social session. It's not, oh, look, the school's closed. Let's go walk around the school when nobody's here. That's not what this is for. All right, this is for you either A, come in with questions for me, or B, you just want to come in, have a nice quiet space, and try to knock out some problems while I'm here. That's what review sessions are for. I'm not up here talking at all during a review session. Not at all. It's for you guys to come, sit down in a group or by yourself. You have a bunch of questions you want to ask me, or you want to just sit quietly somewhere and knock some questions out. That's what the review sessions are for. Next Tuesday morning, I'm not going to be available. All right, you don't practice the day of a game. All right, so that's my mindset. All right, all the hard work's over and you're ready to roll. Try to be there 15 minutes before the exam starts at 8 a.m. because we do start letting people in early. And by the time we have our exam, you're going to have like 4 under your belt already, so you'll know how the setup goes and when you walk in and what's expected. Hey, how about those textbooks? That'd be great if I could get those back from some of you. Let's get those back, please. And also just a reminder, you need to borrow a compass or a calculator. I'll be seeing you for at least 30 minutes for a review session with me if you need to borrow one of those things. If not, I'm not going to bring any of the exam and you're kind of out of luck if you need one. All right, so please remember that if you need something, come to a review session. Anything I can answer there, just some reminders. Get your calculator out. Let's go over one. Actually, tomorrow will be the last time, but second to last time here. How do I clear my calculator when the time comes? So I don't have to stop Mr. Carlino and ask him because he's just going to pat me on the back and say, good luck, young buck, and move on. First set. Second plus. Number 7, scroll over to all, yep. And then pretty easy from there, all memory, reset. Got to see the mem cleared on there. All right, that's all I need to see is mem cleared. And then from here, after I give you the okay, whether you get reminded or not, where you got to go very next step. We're going to get all the sine, cosine, tangent problems wrong if we don't. Mode, and make sure your calculator's back into degree mode, and make sure your mindset physically, mentally is in beast mode, ready to go for this. All right? We're all good. Anything you guys want to ask about the exam that maybe I haven't, seat numbers, you got that on your sheet or on Google Classroom, so you know where you're sitting. And on your desk should be your bubble sheet when you guys walk in with your name on it. So everything's done in pen except for a construction or anything you do on graph paper. And if you have questions about it, just ask me. All right, so here we go. I do want to go over one multiple choice question with you that we haven't covered yet, and then I'm going to see how many you can get right today. All right, how many multiple choice you can get right in a certain set of time. So go to number 24 on that exam now. 24, please. We're going to go work backwards. 24. I just want to make sure we are clear on something. Do I have the wrong? I have the right one up, right? Okay, just making sure. June 2018, June 2018, June 2018. All right, we have talked about dilating lines before. So here's a line I'm going to dilate. Y equals negative 3x plus 6. And they're saying your scale factor, dilate it by 2. What do we know about lines when they get dilated? They remain parallel. So what stays the same? The slope. So far, the slope of this line is negative 3. So the slope of the new line is going to be negative 3 as well. And what I have shown you guys through our review is that to get the y-intercept, you take the old y-intercept and multiply by 2. And that's why choice 1 is there. But that's not the case here. All right? That, I don't know if you want to call it a trick or not, where you multiply the old one by the scale factor, but that only can happen if you reflect at the point of the origin. Okay? That only happens at the origin. All right, so multiplying by the scale factor you can only do if you're dilating around the origin. Am I dilating around the origin? No, what point am I dilating around? 0, 6. All right, 0, 6, so that's going to be something different. And here's how it's going to work. At the end of your test, what do you have? You got 2 sheets at the end of your test. What are they? Formula sheet and graph paper. So I would probably throw this up on a graph, and I'll do it for you guys here because I know you probably don't have a sheet available, but that's fine. So let me throw this up here right now so you can see exactly what I'm talking about. Negative 3, 6. 1, 2, 3, 4, 5. Y-intercept, we're all good. Down 3 over 1. Down 3 over 1. Oh boy, come on. All right, good enough. Where's that point that I'm supposed to dilate around? Where is 0, 6? Notice where it is? Where? It's already on the line. All right, it's already on the line. Anybody remember when we were doing these? If the center of dilation is already on the line, what happens to the line? Nothing. It stays the same. Because look, scale factor of 2 means I'm getting further away. All right, so this point's going to get further away. Guess where it still ends up? On the line. This point ends up further away. It's still going to end up on the line. In summary, if you dilate around a point that's already on the line, it remains the same line. Okay? You cannot do the multiply by the scale factor unless it's around the origin. So I want to make sure we're clear on both types of dilation problems. If it's on the line, it stays on the line. And the only way you're going to know that is if you throw it on a graph. Okay? And you look on a graph and take a look. Questions? Okay, I don't care if you work in your groups or by yourself. I'm going to give you a set amount of time right now. Work backwards from the so you're on 24 right now, 23, 22. I want you to do some of the tougher ones here first. All right, look in your cold hard fact sheet because there's going to be a formula you're not familiar with. All right, let's get it done right now. Let's go. I'm going to only give you a set amount of time, and then don't look up the answers. Don't cheat. Don't look up the answers. You do what you think is best. All right, get your cold hard fact sheet out. Get your sheet, your formula sheet that's not given to you out. Let's go. Get all that stuff out so you can look it up. And then we will go over it I'll give you guys a set amount of time. Start. All righty, 23. Anybody see a key phrase in 23 that I didn't even before I tried to set up a diagram, I knew what I was going to use to solve it. Altitude to the hypotenuse, so we should have used what here? Hills and SAS. That is correct. Hills and SAS. And it should have looked like this. 24 hypotenuse over leg 10. Same leg 10 over segment next to 10, which is the one we were trying to find, I believe. And then you cross multiplied and hopefully got 4.2. Questions there? Ask away if there is. 1 for 1. All right, next up. Not that one. Go backwards. 22. Had to hopefully look up in your cold hard fact sheet. Maybe you wrote it down, hopefully. Length of an arc. Length of an arc. Measure over 360. Be careful here. If you wrote times pi r squared, that's for a sector. Pi r squared is for a sector, not the length of an arc. All right, that would have been for this right here. If they wanted you to find sector AOB, would have been times pi r squared. But it is the arc length, which is the distance from A to B. So instead of pi r squared, you should plug in the circumference instead, pi d. Okay, pi d. 120 over 360 times pi times your diameter 12. You won't see that anywhere on your choices, will you? Why not? What did they do with 120 over 360? Yep, and again, I go to my calculator, 120 over 360, it'll do it for me. And then you can see how that's the same as saying 1/3 instead. So choice 4. Choice 4. Good so far? All right, let's go right away. In this problem, they tell me SR, ST parallel to PR. What do I know about the two triangles? We've done this over and over, I believe. Similar, so you're going to have to set up a proportion. When we set up a proportion, you use full sides only. Full sides only. So 2 should have never came up in your proportion. Never. And what are we trying to find? QR? A couple ways you could have done this. Let's see here. 5 over 7. That ready? QS over QP, 5 over 7. Now, I'm interested here. Did anybody just call QTX instead? And do it that way? You could do it that way. If I just called QRX, though, how would you tell me what side QT is to put here? X minus 5 over X, the whole thing. Now, just be careful here. Some of you guys shook your head yes when you told me that you put QT as X. That's not your final answer when you solve for X, right? We're looking for QR, so hopefully you added 5. So some of you might have gotten 12.5 out. That wasn't your final answer. You had to add 5 to it. QR, 17.5. Be careful there. All right, 17.5. We making out all right so far? Next one, a little, all right. Oh, God, one job. Come on, going backwards. Force a habit. 20. We got a little circle. I notice O has a center of, I count, 5, 2. Circle formula again. That's the only one you know, right? That's the only one you know. Plug in your center, and we'll find the radius. X, what should I plug in for H? Minus 5 squared plus Y minus 2 squared. Can you guys find how long the radius is of this circle? I hope so. Just draw it to a point. How long is the radius in circle O? 4 units, but I don't put 4 over here, do I? What do I put? 4 squared, 16. So I'm hoping you guys can at least build that on your own. Now I'll take over and help you which multiple choices are going to be. All right, I haven't shown this yet. One way you could do this, and this is very long for a multiple choice, but you take each multiple choice and complete the square, which we did on Friday, I believe, or Thursday last week. All right, you can complete the square. That's going to be a while, because what happens if, I go 1, 2, and 3, and it ends up being choice 4? That's going to take a while. All right, so how can I actually work in reverse? Make one of these look like that. Okay, so let me show it. This is why I picked this one in this exam on purpose. How can I make my circle equation look like one of these so I don't have to complete the square and work backwards? Are you ready? X minus 5 squared is the same as x minus 5 times x minus 5. Can you guys have the algebra ability to multiply those? I hope so. Let me do that just to save time. X squared minus 10x, excuse me, plus 25 after you're done foiling, double distribute. Same thing for the y's. Do y minus 2 and y minus 2. Double distribute. You get y squared minus 4y in the middle plus 4 at the end. Still all equal to... Oh, wow. Okay. That came on me quick. All right. We'll finish the rest up tomorrow. Sorry, that came on quick. Wow. We'll finish this up tomorrow. Textbooks.